Welcome back, ladies and gentlemen. Welcome back, class. Ralph, Rudy, Maria, Lisa, Deborah, Stephanie, Joe, and Joseph. Welcome, everybody, and welcome to the class. Welcome to problem 2. Well, again, we need to determine if this function is continuous at the value x equals 1. And the first criteria, the definition we need to determine if the limit of this function as we approach 1, if it exists. So let's see if it meets that first criteria, if the limit of that function exists. Well, look at that function. In its original form, we cannot use x equals 1. Why? Joe? Yeah, because if x is equal to 1, the denominator is 0, you can't divide by 0. It's undefined. Stephanie? Oh, you do see something. So now, in order to evaluate the limit, whoa! Whoop! I'm thinking integrals here. In order to evaluate the limit, Stephanie recognized, well, we can factor the numerator and to see if we can do something with that. So factor the numerator for me and see what you get. I'm going to give you time to do that. And let's see how we go from there using that information. Remember, even though it might be factorable and something might happen, we cannot use x equals 1 for this part of this function. So go ahead and factor that, and what do we get? Let me give you time. What does that look like? What does the numerator factor into? Let's see. Maria? Oh, you do? Okay, do you agree with what Maria said? Maria recognized that the factors of 2 is 1 and 2. So she said that she could factor it this way. F of x equals x minus 1 times x plus 2 all over x minus 1. And notice, because 2 minus 1 is the middle term, it's positive. Now what do we notice? What do you notice now? Joe? Yeah, there are common factors in the numerator and in the denominator. Those common factors, they do cancel, do they not? So I know that this factor, remember these represent numbers, this factor and this factor, they divide into one another once. Do you see that? So now I know that I'm left with x plus 2. So yeah, we can evaluate the limit of that function as x approaches 1. So let's go ahead and do that. Let's go ahead and do the left and right hand limits. So now again, I'm going to draw a number line up here. And here goes the value of 1. And I'm going to draw, and here goes 2. And here goes 0. And now I'm going to draw what's called a deleted neighborhood. I'm going to get real close to this as I approach it. So now the limit of f of x as x approaches 1 from the left. So I'm right in here in this little neighborhood here. So in this case, that's like 0.9999. As I get closer and closer to 1, I'm going to let x equal 1. So now that gives me 1 plus 2, and that's equal to 3. So far, the left-hand limit is 3. Let's take a look at the right-hand limit. The limit of f of x as x approaches 1 from the right, again, it's between 0 and 2, and it's in between here, close to 1. So we can use that again. So now we can say, well, in this case, let x equal 1 again. It's 1 plus 2, that's equal to 3. So since the left and right hand limits are equal, I know for sure that the limit of f of x as x approaches 1, that becomes equal to 3. So the limit of that is 3. It's limiting. It's getting closer and closer to 3, so we can actually say that the limit of that is 3. So the limit exists. So we just shown that the limit exists. So we've met criteria 1. Next criteria. It says, is the function defined? So now, criteria 2. From the definition. Criteria number 2. Well, yeah, it says that in this case, f of 1 is equal to 5. So the function is defined at x equals 1. So criteria 2 has been met. The function is defined. Criteria 1, it does have a limit. Next step, criteria 3. Whoa. Criteria number 3. Well, in this case, here's what we know. That the limit of f of x as x approaches 1, that's equal to 3. And that is not equal to f of 1. It is not equal to f of 1. So the limit of f of x as x approaches 1 is not equal to f of 1. And f of 1 is equal to 5. So the limit is not equal to that function defined at that value of 1. So since the limit, the third criteria, is not met, what conclusion can we draw about the continuity of that function? Let's see, Audrey. Yes, because since the third criteria is not met, the limit of that function is not equal to the defined value of the function. That function is not continuous at the value x equals 1. So, by criteria 3 of the definition of continuity, by the definition, f of x is not continuous at x equals 1. So now we have shown mathematically that f of x is not continuous at the value of x equals 1 because the limit of that function is not equal to the function where it's defined. We know that f of 1 is equal to 5, but the limit was 3. So 3 is not equal to 5. So by criteria 3 of the definition of continuity, that function is not continuous at that. Alright, so what I'm going to ask you to do now, I'm going to move out of the way. I'm going to ask you to copy all of this. And then the next thing we're going to do, we're going to look at graphing this to see what it looks like. And that will conclude our work on problem number 2. Let me move out of your way. Please copy the remainder of the work from the board. Please let me know whether the steps that I went through so far, whether they have been clear, whether I did a good job of helping you to gather a better understanding of how to utilize the definition of continuity. At this moment, please pause the video. I need to erase part of the board in order to do the graph, to put the graph on the board to see what this looks like. Please pause the video at this moment to finish copying the work. Thank you so much. Okay, ladies and gentlemen, we are back. And here goes our graph. Here goes the graph. I took the liberty of graphing it. And here goes our function, f of x. And here it is. Here goes f of x. Notice that the value 1, it should be 1, 3, but it's not defined there because by the original function, we can't use x equals 1, so there's a hole here in the graph. But the function was defined to be 1, 5. This is called the removable discontinuity. So this discontinuity was removed, it was put up here. It's removable discontinuity, there's a hole in the line. So therefore by this we can also see that this function is not continuous at the value where x is equal to 1. So in this case, we've shown mathematically by the definition, by the third criteria of the definition, that the f of x is not continuous at x equals 1. Okay, let me give you time to copy this if you have not done so. Thank you for joining the class, everyone. Very good job today. And I'll see you in problem number 3. Let me know if there's any difficulty in understanding what I did. Let me know whether the pace that I covered, whether it was good, if I moved too fast. Let me know if it was clear. I want to know if I made this crystal clear to you, because your comments will help me to grow, to become a better instructor, and do a better job at communicating mathematics to you. That's what I want to do. So I do look forward to your comments. Thank you for joining me, and I'll move out of your way, give you time to finish copying that. Please copy the graph. I'll give you about 30 seconds, then I'll ask you to pause the video, and we're going to move on to problem 3. Thank you for joining me today. Okay, please, at this time, if you've not completed the graph, please pause the video at this time. Thank you for joining me. I will see you in problem 3. Thank you so much. Have a very good, excellent day.